All right, today is our first lesson on logs, and our goal today is going to be able to convert things from exponents to logs and then back again. We are not solving anything today. We are just trying to simply figure out how to change form so that we have the ability to solve later. Now, to understand this just a little bit better and to try and figure out what exactly a log is, and we'll get more in detail as we go through here, this is just a starting point, I want us to think about solving these two equations. So on the first one, to solve it, we would divide both sides by 2, and you know that. Okay, but the reason we do that is because the opposite of multiplication, right now this 2 is multiplied by x, the opposite or the inverse multiplication is dividing by 2. All right, so that means if we're looking at this equation over here, we have to figure out what the inverse of raising something to the x power is. Now, you might start to say it's a square root, but when we did that, we had a number in the exponent, and then we could take the square root of it. But that's not what we have here. Now the exponent is a variable, so it changes things. Well, if you didn't know how to solve it, you could reason through it and start plugging in some numbers and seeing, okay, well, 2 to the first power is 2. That's not right. 2 to the second power is 4. That's not right. 2 to the third power is 8. Okay, so x must equal 8. And that works just fine if it's something simple. But later on, it's going to be more complex, and we can't really do that. So what we do is the inverse function of a exponent is a log. And we would write this as log, and if we were looking at this part of the fraction, the 2 is the base and the x is the exponent, right? So we'd say log base 2, and then the x and the 8 switch places, of 8 equals x. So the way we say this is log base 2 of 8 equals x. Now this one we could solve without a calculator because we just did it, but if we had something that was not solved without a calculator, this is where we'd plug it into the calculator. But that's Wednesday's problem. Let's focus on this. This is how the book writes out the definition, and I think it would be important for you guys to write down this part of it. So you have the example as a conversion. So the way we would read this over here, starting on the left, is log base b of x equals y. And then when it's written as an exponent, b is the base, and the x and the y kind of change places, don't they? Okay, but whatever it equals becomes the exponent, and then log of whatever is what it equals. Okay, so I know that's a little weird, but don't let the video go any further until you have that in your notes. So here are some examples. So the first one is 5 to the third equals 125. And you're saying, well, there's nothing to solve. 5 to the third is 125. And you're right. We aren't solving anything. We're simply writing it a new way. It's like saying that, okay, I'm 42. So I could say I'm 42, or I could say that I'm 40 plus 2. It's the exact same thing. I mean, it's not as convenient, but it's the exact same thing. We're just writing it in a different way. So this first one, to rewrite this, would be log. The base of this part over here on the left is the 5, so that's going to go down low. And then the 3 and the 125 switch places. So base 5 of 125 equals 3. Again, not solving, just rewriting. The next one, 8 squared equals 64. To rewrite that, it would be log base 8 of 64 equals 2, because the 2 and the 64 swap. Let's try some more. If they have variables in there, that doesn't matter. I would say log base 6 of 1296 equals x. Same thing over here. Now, you see how I have number 3? That's something that we're going to learn how to solve next time, but we're just prepped today. All right, log base 7, except that looks like a 2. Try again. Log base 7 of x equals 3. The other one. Now we've got 2 variables. Still doesn't change anything. 9 to the x equals y. So I'd say log base 9 of y equals x. Because remember, got to flip those two things. So the last one, 5 to the negative second equals x. Well, I could write log. My base is 5. These two switch places. So negatives are going to show up in here, and that's okay. No big deal. Okay, we're also going to have some fractions later. No big deal. All right, now we need to rewrite this one. We've got logs and we're writing them as exponents. Sorry, I lost my train of thought. So this right here is your base. So we're going to have 4, these two switch places, squared equals 16. Okay, I mistyped this one, so we're going to rewrite it. Okay, so if I'm going to rewrite this one, it would be 2, and then remember, these flip-flop, so 2 to the 5th equals 32. Oh my gosh, it does. It's like it's equal. Okay, over here on the next round, this would be 5 to these two flip, x equals 625. Now, written like this, the way I have it 9, that would be a little bit difficult to figure out. But if I could write it as that log form, then that's something that I could enter into my calculator and figure out the answer to. Over here, this one would be 8 to the x equals 512. All right, 2 more. This one you got x's and y in, still totally fine. So I have 9 to the, flip these two, y equals x. Okay, this one I got a fraction in it. So what? It doesn't matter. We can still solve it. Okay, and let's look at this one. We're going to take this one step further. Okay, so this would be 9 to the 1/2 equals x. So this time written as a log, that wasn't solvable. But now 9 to the 1/2, we know how to solve that because that means the square root of 9 equals x. So x equals plus or minus 3. Oh my gosh, we did that in the last chapter. It's like everything's connecting. All right, that's the video for today. And now you're going to go pull up your homework. You're going to show your work on a separate sheet of paper and then use your phone to submit your answer key to, or your answers or your homework to the Google Classroom. Good luck.